What's up everyone, Jessica Dean here. I'm super excited for today's video. I'm gonna walk you through just how easy it is to set up an Azure Application Gateway V2 with an existing Kubernetes cluster. Now you might have seen one of my earlier videos where I walk you through how to use a Helm chart and set up an Nginx Ingress controller with also your existing Kubernetes cluster and resources. And that's great because it works with any cloud. It's not specific to Microsoft. But today we're gonna hone in and focus specifically on Azure Application Gateway. Now you might be wondering, what is Azure Application Gateway? And honestly, I'm so glad you asked. App Gateway, or Application Gateway, is a layer 7 load balancer that supports HTTP, HTTPS, HTTP2, and even WebSocket. And it uses something that's called an Application Delivery Controller, or ADC, as a service. I know, other things as a service, but the best part about that is because it's a service, it's highly available, it's scalable, and it's fully managed by Azure. So it's something you would use in lieu of using an Nginx Ingress controller, because again, it's something that sits at layer 7 and it doesn't sit physically in your cluster. A component of it does, but not the actual load balancer itself or IP address. And so we're gonna walk you through how to set up all of those resources. Let's check it out. All right, so I already have all the commands we're gonna need to create this up on my screen, and there's gonna be links for them down below. In fact, I even have a blog post that'll walk you through this as well. Now, I'm a huge fan. If you have followed me at all, you probably already know this, but I'm a huge fan of using variables in any of my commands. That way, I don't accidentally screw something up, especially if I'm going to be referencing the variable or what that variable represents multiple times. So you can see right now I have lines 5 through 8 highlighted on my screen. These are going to be the variables that we're going to use. So I'm going to copy them. We're going to paste them in right here. And actually, I want to make sure that I have access to that Kubernetes cluster. This is going to be one of the key things is you're going to want to make sure if you have multiple Kubernetes clusters that you're using the right one. So I'll just do AKS get credentials, and I'm going to get both my resource group and my AKS name. I already have my AKS name parsed in from a previous command I've run, but if you didn't, you would just physically type that in. So you can see here's my cluster right here. So now I have a nifty little add-in in my terminal called kubectx for my kube config, and I can select it and make sure I find that new cluster. Now to show you, it's completely brand new, but it's existing, right? I didn't set any of these resources up with App Gateway, and that's gonna be the purpose of today's video. I can do get pods and hit enter, and you'll see that I don't have any pods. I could do Helm ls, and you'll notice I get an error because I don't even have tiller. That's because if I do Helm version, you're gonna notice that I still have Helm 2 installed, but I also have Helm 3 installed and I'm just using an alias. So we can do H3 version, and you'll see here's my 3.1.2. And again, still showing you that there's nothing funny going on, H3 ls. Great. So now that we've kind of level set and checked our clusters, we can see that we don't have anything. Let's go ahead and start creating the resources we need. First off, we're going to need a dedicated subnet. Application Gateway needs to use a subnet that's not in use by any other resources. So we're going to just copy the subnet command over and we're going to paste it in. Now, while it's running, let's break down what it's doing. First off, you see that it starts with AZ. In fact, if I highlight AZ, you'll notice a bunch of my commands start with that. The reason for that is I'm using Azure Command Line, which is cross-platform. It supports Linux, Windows, and Mac, and it is the command line interface, or CLI, for me to interact with Azure and with all of my resources. I'm already logged in, and I can very easily start creating resource objects. You can see I just created the subnet, and I can see that the provisioning state is succeeded. So now I'm going to go through and I'm going to create a public IP address. I need my public IP address and I need to attach it to the application gateway. This is where that layer 7 that we talked about, that's outside the cluster, all of these resources are going to live on the outside. Then we'll simply have a pod living on the inside of your cluster that'll interact and communicate with these physical or virtual resources. So you can see right here, if I scroll up, I got another provisioning state succeeded, and that created my public IP address. I can even see specifically what that public IP address is. So now we'll go ahead and we'll clear the screen. I'll scroll up one more time, and we're going to go ahead and grab our final command. Let's go ahead and paste this in, and we'll break this down too. I'll even zoom in. So let's take a look. Again, I'm using Azure command line, AZ, and you'll notice that both with my public IP address, my subnet, and now with Application Gateway, I keep referencing network. That's obviously because we're doing networking commands. So I do AZ network, and I want to create an application gateway. I'm giving it a name that's equal to the variable I set in the beginning. I'm giving it a location. I'm providing the resource group name, again, equal to the variable, the name of my virtual network. This was the VNet that lives within my Kubernetes cluster that was pre-existing. Remember, we just attached a new subnet. This is hard-coded only because I'm not referencing it that often. I reference it in really just a handful of places, though you could make it another variable if you wanted. You can see I have the subnet name here, app.gw subnet, and if we go back up, I still have app.gw subnet here on line 12 when we created our virtual network subnet. From there, I just start setting a few other SKU settings. These are things that are specific to what I want for my application gateway. You're more than welcome to check out the docs down below and figure out what works best for you. Now, this will take up to possibly 5 minutes to deploy. And so once this is completed, we can move on with the next step. All right, so that's done and it completed successfully. If we wanted to triple check and trust but verify, we can scroll up and again see our provisioning state is succeeded. So I'll clear the screen here. And now just to recap, we have a virtual subnet or virtual network subnet. We have a public IP address and we have our app gateway. But now we have to do some customizations. First, one of the things I want to make sure that I handle is my firewall. I want to actually enable firewall mode detection on the app gateway itself. So to do that, I can use a command, again, still in Azure CLI, application gateway WAF config. Now this command is being deprecated and it will be changed to something, I believe it's WAF policy. And actually, yes, you can see that right here. Use network application gateway WAF policy. So definitely check out Azure's docs to see how to do the same settings. But for right now, since this is still working, this is the command that I'm going to go to. After the application firewall gets set up, or the application gateway firewall, then we'll need to start setting up some health probes. This is where I can verify that my application gateway is responsive, that it's actually listening on port 80, and even 443 for HTTPS. So we'll let this command run. This can take probably about 60 seconds to maybe 2 minutes, and we'll check back in when this is done. All right, so this completed successfully. And again, we can always double check that our provisioning state is succeeded. We can scroll up just a tad and find provisioning state succeeded. Perfect. All right, so we're gonna go ahead and clear the screen here. And now we'll work on those probes. So both commands, you can see here's 49 through 56. We'll zoom in. You can see, again, I'm just creating a probe. I'm calling the first one default probe HTTP. You can give it whatever name you want. This is what works for me. And I'm setting the protocol to HTTP. The host is localhost, and I'm just gonna point it to the root path. Now for HTTPS, the only thing I really change is the protocol and then the name. So we'll go ahead and run these in succession. I'll copy this one. We'll zoom out. Whoops. Let my mouse get away from me. Paste this in. These commands should run fairly quickly because they're not doing too much. And I'll get my HTTPS command ready on my clipboard. There we go. Now we're gonna go ahead and do HTTPS. Okay, perfect. So now that that's done, we're ready to actually link our first HTTP probe, which is again, checking port 80. We're gonna link that over to a backend setting. This is just starting to set up some routing. So we're gonna go ahead and grab this command and we'll clear the screen down here. Whoops, can't type clear. Paste this in. And I'm going to zoom in here real quick and hit enter. So you'll notice, just like our other commands, again, I'm still using network. I'm using Application Gateway, only this time I'm going to update some HTTP settings. I want to make sure that I set the backend HTTP settings, the default routing, to that probe that we set for port 80. Because if something isn't working, I want it to be able to tell us based on just standard HTTP, right? Normal routing is going to go through 80. You can also do it for 443 if you want, but this will actually cover both to where your app gateway will support either 80 or 443. So we'll go ahead and zoom out. You can see again, the provisioning state is succeeded. Now we'll scroll up, or by the way, I keep saying up because I'm using my Mac OS mouse and I keep pushing the little mouse up. So everything's inverted. Damn Apple. Anyway, now that we have our actual app gateway configured, we're ready to move on to part 2 of this process, which is setting up a managed identity to actually handle the communication between what lives in our cluster and the resources that live outside of our cluster. This is so we can still schedule stuff without having a username, password, or service principal. So first, because I have an RBAC enabled cluster, I'm going to run a series of CRDs. This comes from the AAD pod identity Helm chart repo, the official repo. Normally be careful what you run. If you're curious, if you have RBAC enabled on your cluster, which unless you're a barbarian, you probably should, you can do kubectl or kubectl, kubectl, whatever you want, and type API versions. If you have something that says RBAC, chances are you have an RBAC enabled cluster. So since I'm not a barbarian, I'm going to go ahead and copy this. We'll paste this in and we'll let it install several CRDs. Now, once it does, it's actually creating more than just custom resource definitions. It's actually going to set up a few deployments. So if I do get deploy, can't type, you'll see that 11 seconds ago after I ran that, I now have a deployment called Mick. If I do get, I think it's a daemon set. Yep. I also have something called NMI. This is going to handle my managed identity. So both of these, if I do get pods, now have pods that are spinning up ready to handle whatever we schedule. But we have to give it a resource or an identity to use. So the first thing we'll do is we'll create an identity itself, and we're just going to drop it in our same resource group. So we'll clear the screen here, and I'm going to create the identity. After the identity is created, we need to assign that identity permissions. Now, we don't want to go overboard because we don't want to just give godlike permissions to everything, but we want to give enough permissions so we'll be able to actually use the application gateway resource in our cluster. So I'll clear the screen here, and I want to capture a few key details. First, I want to get the client ID from the managed identity we just created. So I'm going to copy this command, and you'll notice that I'm outputting that ID again in an environment variable. Like I said, huge fan of anything I'm going to reuse several times. I can confirm that I got that by echoing back that client ID. I'm going to do the same thing with my app gateway ID. This is the ID of the resource itself. So I'll go ahead and capture that in an environment variable. And again, we can echo app gateway, and we'll make sure I'm doing ID. You can see here's the full ID. Obviously, I don't want to hard code that anywhere. You'll also notice that I have single quotes on occasion when I'm using my queries. That's because I'm using ZSH in my terminal, and if I don't have single quotes, I'll get a really weird syntax error. So, fun fact, always use single quotes when you're doing that. Also, I'm outputting it to TSV. You can see TSV right here, which stands for table separated values. It's a little bit easier of a way for me to parse JSON without having to output it, pipe it over to JQ, -R to remove the quotes, and all that crazy stuff. It's a lot easier for me to recycle. So the last environment variable I definitely want to grab is also the resource group ID. And you'll see why we need all three of these in just a moment. We'll grab this. Again, I'm always going to verify. We want to make sure we have it proper. So we'll do app gateway RG. And you can see there's my resource group ID. Now we're going to give it the permissions that I mentioned. We need to give the identity itself, the gateway resource itself, a contributor level access. So we're going to go ahead and copy the role assignment command to create a contributor role. You'll notice that, we'll zoom in here so you can see, the assignment is going, or the assignee is going to be the client ID we exported, and then the scope is just going to be that gateway, that GW ID. So I'll hit enter. The reader, which you can kind of see is right beneath that, is a little bit different than the contributor, particularly because of how we're defining the scope. So let me grab this command. You can see the previous contributor was created successfully. We'll clear our terminal screen, paste this in, and zoom in. So we're assigning, again, still the role of reader. We have the client ID is the assignee, only now we're specifying appgw rg. This is going to be for the resource group. This is so it can see all the virtual machines and resources in the resource group where we have our Kubernetes cluster, our app gateway, public IP address, you name it. So we'll go ahead and zoom out and hit enter. Now we're done with the managed service stuff. We're done with creating our app gateway. The third and final piece is tying all this stuff up to our Kubernetes cluster. So to do that, we're going to need to make sure that we capture some of these resource object IDs and environment variables in environment variables. So we're just going to grab this block of code and I'll explain what it's doing. Let's clear the screen. We'll paste this in and let's go ahead and zoom in. First, I'm going to make sure that I capture the application gateway name. I know I set different names earlier on, but this time we want to make sure that we're capturing whatever got deployed. This is going to be one of those trust but verify. Don't trust me. I make typos. We're also going to make sure that we capture our subscription ID in an environment variable. And then we're going to get the identity client ID. While I know we have captured our client ID in the past, we're going to redo it just to make sure nothing's changed. And same thing with our resource ID. So I'm going to go ahead and hit enter. And once this is captured, we can, again, echo all these out, make sure that everything still looks good. Nothing is blank, because then we're going to need to parse these environment variables over into a Helm file that we're going to ultimately use to deploy into our Kubernetes cluster. So let's just do a quick application gateway name echo. That looks good. We'll echo our subscription ID. There we go. That looks good. And we're going to do echo identity client ID. Great. And identity, let's drop this down so you can see that. Resource ID. And there's our resource ID. So all of that looks good. It looks like we're ready to go. We'll clear our terminal screen. And just to make sure I don't have a Helm config file local, I'm going to remove anything. We'll do a quick ls. And I see an old YAML file, but I don't see any helm config.yaml local here. So I'll clear. And the reason why that's important is because I'm now going to get a sample config file that's blank. So we'll copy this to our clipboard and paste this in. And you can see it just downloaded and saved to helm config.yaml. Can do an ls. And now we should see a helm config.yaml right here. So we'll go ahead and use code to open up our Helm config. And you'll notice that we have a few things that we need to fill in. We need to fill in our subscription ID, our resource group, application gateway. We also need to fill out our AAD pod identity information, because again, this is what our Kubernetes cluster is going to use. One thing I'm going to manually change is the RBAC enabled. I'm going to set this to true and I'll hit save. This part right here for our cluster configuration is being deprecated, so you can just ignore that for now. So we'll close this, and rather than manually typing all those things, it's too much work, we're going to use those environment variables that we just exported, and we're going to use a good old friend sed to parse all those in. So I'll clear, paste this in. All of that has been actually applied to our Helm config, and we can reopen our Helm config YAML just to make sure that looks good. So you can see now we have a subscription ID, we have a resource group, we have a name. I'm only using a static IP, not a private. I can scroll down. There's my AAD pod identity, my resource ID, my client ID, and obviously I had already enabled RBAC. So that looks good. Now we're ready to actually install our application gateway Ingress that's going to live inside our cluster and communicate with the external resources. First off, if you are using Helm either 2 or 3, you're going to want to make sure that you have the application gateway Ingress repo added in. So I already have it right here, but if you don't, you would just type in Helm repo add and you'd add it. Since we're going to be using Helm 3 for this, I'm going to type in H3 and I'll just paste in, whoops, I didn't copy it. We'll clear the screen there. H3, and grab this properly now, copy, and paste this in. Even if you already have it, you can add it, it's idempotent. And then we'll just do a good old repo update, make sure it grabs a fresh list of charts. Once you have that, you're ready to actually install. So let's go ahead and grab this command. I'm just going to grab up to Helm. I'm going to clear the screen. We'll type in H3 again and paste this in. Now let's zoom in here and break down what it's doing. First off, I'm going to tell it to set it up for upgrade. I'm going to use the flag install if it hasn't already been installed. I'm going to name the release. This is very important in Helm 3 because unless you give a name or use -- generate -name, you'll get a failure. I'm going to specify that Helm config that we just created and just you said. And then I'm going to give it the name of the Ingress chart itself, which somehow repo update got added in there. So we'll just delete that. There we go. So that command looks great and we'll hit enter. Now you can see that the resource doesn't exist. It's going to go ahead and install it. Once it installs it, because we're using pod identity, if I do get pods, you can see that it's working on creating this ingress. Now I could even check the logs of the identity controllers and make sure that it's actually assigning the identity and letting the deployment install. Before we move on to the actual testing of the deployment, you want to make sure that our ingress for App Gateway is in a ready state. So I can see that it's running. We can do, let's go ahead and zoom in here real quick so we can do some troubleshooting. We'll do logs and I'll tab this over. You can see it's working on creating an authorizer from our managed identity service, or managed service identity. It's clear. We'll do logs and we'll type over, let's see. Yeah, I kind of have to guess which pods they are. This one looks like it's correct. I can only tell because I've done this a lot of times. So if we scroll up, you should be able to see this right here, that it got assigned the ID. It updated the user assignment on the particular node pool or virtual machine scale set, and it assigned the identity for our ingress itself. And you can see that if I scroll over, it changed the status to assigned. So now we can do get pods again, and our app gateway ingress is now in a ready state. So now we're ready to actually use this ingress with the public IP address. So the first thing we're going to do is I'm going to deploy out a Jenkins build server in my Kubernetes cluster, and I'm going to do it in 2 different namespaces. So I'll make sure, just like what I did with my Helm config, that I don't have a Jenkins values file here. We're going to go ahead and wget this file that I provided for everyone. We'll clearly I can't type. This is why I use variables. And we'll zoom in here, and I'm just going to paste that file. So you can see if I drop down, do an ls, you should be able to see the Jenkins values file right there. So we'll go ahead and open the file. There's nothing fancy in there. It's just a simple deployment. I'm giving it a master tag for the version, resources. I'm installing some plugins. I'm doing some Groovy scripts. And right here is where I have my ingress. Now, if you take a look, you'll notice that the ingress class, whereas in the Nginx ingress controller, again, I did in a past video, link on the screen. For that, we specified Nginx. Only in this ingress, tongue twister, ingress class, we're specifying Azure Application Gateway. Now, I'm going to override the host name when we actually do the deployment, so I won't make any changes here. We'll just close that. Now, I want to capture a public IP address. I want to get that very quickly. So we'll clear, paste that in, and we're going to go ahead and echo that back. Echo public IP, and I'll copy that to my clipboard. And the reason why is before we actually deploy out our test, we need to make sure that we set up DNS for that public IP address so we can actually even use the host name that we just briefly mentioned. So to do that, I'm going to switch over to my browser. Great. So here's my browser, and we'll go ahead and blow this text up just a little bit here. We'll drop some of these tabs back, and you can see that I have Azure DNS already pre-configured. Again, I did this very similar in Nginx. If I drill down into my Azure DNS, and again, I'll link to blog posts and different things, you can learn how to do this. I have a bunch of wildcards that I'm using for various Nginx or application gateways. And I have one right here that's assigned to wildcard GW. Now this is assigned to one that I tested out for this particular video. So instead, we're just gonna remove that IP address and we'll add in the IP address that we just exported, 52.177.26.22. And because I'm setting the wildcard.gw.az, anytime I go to blank.gw.az.jessicadean.com, I should be able to see at least some sort of reference to Application Gateway, if not my application itself, if that's the DNS name that I provided at the time of deployment. If that doesn't make sense, it hopefully will when we play with Jenkins. So let's go back up and just double check that GW, let's zoom in, 52.167. Let's see, that hasn't refreshed yet. Let's go ahead and refresh here. And there we go, 177.26.22, 177.26.22. So now let's just go ahead and give that a test. Let's do test.gw.az.jessicadean.com. And you can see I have a bad gateway. That's fine. We haven't deployed anything to it, but I am getting a return of Azure Application Gateway v2. So now let's deploy shit. Let's have some fun. Scroll down here. I'm going to create two different namespaces. First off, I'll do demo 1 as my first namespace. Paste. And we'll do demo 2. Create these namespaces side by side. So I have two different namespaces. And I'm going to do two different Jenkins deployments into those two different namespaces. So first off, we'll paste our first deployment. And again, you'll notice, just like what we did before, I'm using Helm 3. I'm doing upgrade, install if it doesn't exist. I'm giving it a name. I'm forcing it into the namespace demo 1. And then I'm specifying the values file that we looked at. And I'm setting that Ingress hostname to be equal to demo1.gw, right? That's the DNS prefix that we just set up, and az.jessicadean.com. And then I'm also referencing, that's getting cut off here, but it's stable Jenkins. So I'm gonna use the stable upstream Helm chart. So I'll hit enter. And this is going to deploy out Jenkins 1 release into the demo 1 namespace. My brain kind of paused there. We're going to do the same thing with Jenkins 2. So I'll copy this and I'll paste this in. So again, if we kind of zoom in, you'll see Jenkins 2 is going into demo 2 and the host name is demo 2. Now with Helm 3, if you're new to Helm 3, if I were to just do an H3LS, you're not going to see Jenkins because Helm 3 list commands are now specific per namespace. So I'd have to do H3LS demo 1, and we'll zoom in so you can kind of see the command, H3LS demo 1 or H3LS demo 2, and that's where I can see Jenkins 1, Jenkins 2, the revision, and the deployment. I can also do k-get pods, and we'll do demo 1, there we go, and we'll do demo 2. Now both of these are still in an initializing stage. This can take about 3 or 4 minutes to fully deploy. So, and you can see it's about 52 seconds old or 36 seconds. Let me go ahead and start a new TMUX session because I can split my screen here. So we'll split this and we'll do k-get pods demo 1-w and we'll do k-get pods demo 2-w. And we'll just keep a little watch on this until both of them are in a ready state. Once they're in a ready state, we should be able to actually go visit our new applications at our application gateway DNS that we just set up. All right, so you can see that both of them are now in a running state with 1 out of 1 ready in both cases. So let's go ahead and zoom out. I'll clear the screen here and I'll clear the screen here. Now let's go ahead and do kget ingress, and I'll do demo 1 and kget ingress demo 2. We'll zoom back in temporarily. You'll notice in both of the namespaces, I have the hosts that we defined when we deployed out our Helm releases for Jenkins. And you can see that I have the IP address equal to the gateway because we're using Azure Application Gateway. So we'll zoom out, we'll go back over to Chrome here. Now I'm just gonna do, let's zoom in just so you can see this. We'll change this to demo 1. And I can see welcome to Jenkins. That looks great. And I'm going to do the same thing for demo 2. And then there's welcome to Jenkins. And so that's how easy it is. You kind of have to break it up into 3 stages. Is first off, you need to set up your application gateway resources, your designated subnet, your public IP address, the gateway itself. You configure anything that you need for it, your HTTP probes, backend routing, all of that stuff. In fact, we can even take a look at those. So let's refresh our resource groups. We can find our app gateway JD AKS. We'll take a look at what actually, there's our managed identity. We'll scroll down a little. Here is our application gateway. And when you drill down into even some of the backend pools, we should be able to see we have our Jenkins 1, Jenkins 2, and there's our default address pool that we've even linked over to some of our health probes that we created. You can see there's our health probes. Jenkins will create their own as well. Here's our local host with our path. Jenkins is going to set it up to login. It's going to set out a quicker timeout. We were just testing everything from our commands, and we can visually see that. We can even see our application firewall that we set up, and that should be set up to detection. And you can see even you can enable diagnostics. There's a whole bunch of configurations that you can do. Now that all of that is configured, again, breaking it up, you have your application gateway resources, you have your configuration settings. Don't forget about the managed identity where you give it key permissions, and then you just connect it to your Kubernetes cluster. I do have a blog post that I mentioned that will walk you through everything. I have pictures, I have links to documents. We walk through all the different commands, including exporting the environment variables that we talked about. And now you also have the video to go along. So feel free to drop a comment down below, follow me on Twitter, subscribe to the channel, and it was so awesome to hang out with you today. Thanks very much.